Hi, I'm Punita here from Huawei Global Training Center, and today we're going to discuss about the content troubleshooting RF units fault. This is part 11. So let's look into how to troubleshoot RTWP fault. So fault description, related alarm will be reported. Example, RF unit, RX channel, RTWP, RSSI, unbalanced alarm, and RX unit, RX channel, RTWP, RSSI too low. So these alarms will be reported for this case. Let's look into the possible causes. In this kind of situation, the settings of attenuation on the RX channel of the RF unit fault could be incorrect. The feeder connected to the RF unit can be faulty. Passive intermodulation exists. External interference exists. The feeder is improperly connected to the antenna, or hardware in an RF module is faulty. So these are the main causes. So let's look into the troubleshooting method. Step 1. Rectify the fault and modify the improper settings. Check whether got alarms related to ALD antenna line device or TDM are reported. If yes, we have to clear the alarm first. Run the list RX branch to check whether the attenuation of RX of the channel in the RRU configured as per plan. Else reset the RF module, but this one can be done on site. Check whether the alarm cleared. If not, we have to modify the RX branch and recorrect the attenuation value based on the actual one. Okay, let's look into the command. So when you list the RX branch, you will see the attenuation value. So currently it is 0. So this is the value that we have to modify. So let's check whether got any PIM interference exists. Run the add cell simulate to add the simulated load. So this one is similar to the dummy load. After that, we can start the RTWP tracing. So basically, if the tracing values are higher than the curves, the PIM interference exists. If the values of the curves are basically the same, there is no interference. So this one we can run from the signaling trace management. So let's look into this execution. So we start with the status, then we have to go to the signaling trace. So basically, we will start with the cell simulate. So we can see whether got any cell simulate added. This is for the dummy load for this particular site. So for this case, there is no any configuration related to cell simulate. So we can switch to another site and we can check the similar command. Alright, next we go into the signaling trace management. And we have to look into the RTWP or RSSI related command. So basically, it is still under the LT network. So we can look into the cell performance. So we do have the RTWP or RSSI related command here. So this is the RSSI statistic monitoring. So basically, it will measure the values related to the RSSI from the cell level. So mainly it's actually from the cell level. So I'm going to measure based on FDD side or TDD. This data is for the past 24 hours. So we need to have a cell information. So it will start measuring. So basically, if the cell is inactive, we won't be able to see any value. So let's try to list the cell. To display the cell to check the status of the cell. If the cell is inactive, then probably we won't be able to see the RSSI. So currently the cell is inactive, uninstalled. So that could be the reason why we won't be able to see any data here. So this is related to the RSSI. We also have the baud RTWP here. So baud RTWP, you have to configure the baud level. So I'm going to choose the similar site. And over here we have to measure the baud interference. Baud level. So this is RRU level. So RRU information, the cabinet number, subrack number, and the slot number. So currently it is running with some volume here. So it still have 0 messages. So once it has some messages here, we will be able to view the results. So we will be able to view the results once we have some data running here. So this is another sample of RTWP and RSSI related commands. So if the PIM interference exists, use either the following methods to determine the location or device where the PIM is introduced. So one is the breakpoint based PIM. For example, you set 4 breakpoints, 1, 2, 3, and 4. So from the RF unit top to the antenna port, at first disconnect the cable at breakpoint 1, then connect breakpoint 1 to a low intermodulation attenuator and add a downlink simulation load. So if the RTWP value do not change, PIM interference is not caused by the RF unit. If the RTWP value increases, the PIM interference is caused by the RF unit. So this one we have to repeat for other breakpoints. So we can also use broadband online frequency scan from the LMT to check whether external interference exists. This one is best to be done on site. So observe the scan results until the alarm is reported. Then you can send the tracing results, logs, and investigation result to the Huawei team for the fault diagnosis. So this one best to be done on site with web LMT. Then we can also check whether got cross-pair connection exists. The alarm can be caused by a cross-pair connection. It can be reported at least 2 sectors under the same eNode B. RTWP variation of different RF channels are uncorrelated, or variations are similar in different sectors. So what are the methods of troubleshooting the cell with a cross-pair connection? You can perform drive tests and do a trace signaling without interrupting the service, or run the start crossfeed test to start a cross-pair connection test. This best suits if you have this kind of similar network. You have the similar network, that means you have a cross-pair connection solution. All right, if you don't have this solution, then probably it won't be applicable in your network. So let's check whether we have a cross-pair connection concept in our network or not. So we can perform the test to double confirm. So it will be between 2 sectors. So we just have to make sure it is normal. If it's abnormal, then there is a problem that we need to attend on site. So let's check the cross-feed test first. So we can perform the test to confirm whether you have such a solution in your network. It will measure from a certain frequency, but this command, pay attention that it can interrupt the services. So best to be done off-peak hours, and best to be done when you are basically could confirm that there is a similar solution in your network. Like in this case, my base station doesn't support this configuration. If it doesn't support this configuration, then you cannot execute this command. So let's look into troubleshooting ALD link faults. So potential failure points of ALD system. ALD stands for antenna line device. So basically antenna line device system. So it can be related to antenna failure, RCU installation, RCU configuration, AISG cable, AISG connector, and RCU connector. So how to troubleshoot ALD link fault? Fault description, an ALD related alarm is reported if there are ALD link fault in the RF channels of an RF unit. The possible causes is that setting the ALD power supply switch is improper, settings of the ALD current alarm thresholds are incorrect, the ALD connections are abnormal, the ALDs are faulty. So how to handle, rectify the fault and modify the improper settings? If problem persists, contact the Huawei project team for solution. Q&A session. Run the start crossfeed test command to start the cross-pair connection test. Yes or no? Yes, this statement is correct. The level of the intermodulation product increases with the transmit power. Yes or no? Yes, this statement is also correct. So the summary of this section, troubleshooting RF unit faults, is that we have learned about troubleshooting RTWP fault, and we have also learned about troubleshooting ALD link faults. Thank you. That's all from me. Hope you enjoy the session. Bye.